This is it, right?
Yes, sir.
Nice. So the first question, is there any specific order you'd want us to go in?
No.
All right, cool. So let's start with the first one. So the first one, it says find the square root of the complex number 12 plus 16i. So let's do that question first. Square root of 12 plus 16i. All right. So we're finding the square root of 12 plus 16i. Now, only thing we have to know is that when we're finding the square root of a complex number, when you square root a complex number, the result is another complex number. So the square root of 12 plus 16i, what we're going to do is say the square root of 12 plus 16i is equal to some complex number. We can call it maybe x plus yi. So let's just call it x plus yi. All right, let's say that's the answer. So only thing we need to determine is x and y, where x and y are real numbers. So x and y are the real numbers that we need to determine. All right, because we know that when we square root a complex number, the result is a complex number. So let's find x and y. So we have the square root of 12 plus 16i is equal to x plus yi. So what we can do is anytime we have square root equals something, we can just square both sides because we like to solve equations that we don't have no square root. So square both sides. So when we square both sides, what we get is 12 plus 16i is equal to x plus yi all squared. So 12 plus 16i is equal to x plus yi all squared. Nice. Now we have that 12 plus 16i is equal to x plus yi squared. What we can then do is expand the square right here. Expanding this square here, it's going to be first term square, which is x squared, plus twice the product of the two. So it becomes plus 2 times the product of x and yi. So it becomes plus 2 times x times yi plus the second term square. Now when we square yi square, it's just going to be y square I square. Y square I square. Now what is I square?
-1.
I square is -1. So we can rewrite that x square, but then this y square times -1 is just minus y
-y
squared.
squared.
So we can write x squared minus y squared. Indeed. Nice. So we can write x squared minus y squared plus 2xyi. And now we're at equality of complex number. Whenever two complex numbers are equal, then their real parts are equal and their imaginary parts are equal. So what we're saying is 12 is equal to x squared minus y squared. And what we're saying is 16i is equal to 2xyi. So we have two equations, right? Whenever we equate two complex numbers, their real parts are equal and their imaginary parts are equal. All right? So from that, we can form the two equations to say 12 is equal to x squared minus y squared. And then the second equation is saying 16 is equal to 2xy. The second equation is 16 is equal to 2xy. Now if 16 is equal to 2xy, we can divide both sides by 2 to get 8 is equal to xy. So from this equation, what we're saying is that 8 is equal to x times y. Now, if 8 is equal to x times y, we can go further and say, well, let's make y the subject, right? So we can make y the subject and say, well, if 8 is equal to x times y, we can divide both sides by x to say then y is equal to 8 over x. So y is now 8 over x. Now after we divide y as divide both sides by x, so y is 8 over x. We can substitute y as 8 over x into the first equation. So we're going to substitute it into the first equation. And so what we're going to get then is, this implies when we substitute it into the first equation, we're now getting 12. We're getting now 12 is equal to x squared minus y squared. But y in this case is 8 over x. So it becomes minus 8 squared is 64 over x squared. Right? So we get 64 over x squared. Now when we get to this stage now, well, what happened is that this looks like it's going to work out to be a quadratic equation. How do we know that? Well, we don't like to work with x squared in the denominator, so we'll multiply the entire equation through by x squared. We'll multiply the equation through by x squared. We're going to get 12x squared is equal to x squared times x squared. This part becomes x to the 4. So we'll get x to the 4 minus now 64 over x squared times x squared. That just gives us 64. So we get 64 right there. Now when we get to that part now, this looks like a hidden quadratic. It looks like a hidden quadratic. So what we can do now is say, okay, let's bring everything to one side. So we'll bring the 12x cubed over here to have x to the 4. We'll have x to the 4. Bring over the minus 12x squared over here to get minus 12x squared minus 64, and that's equal to 0 because we bring everything to one side. Now that we get that this is equal to 0, what we can say now is, we're looking nice now. We look real nice. We just have a quadratic, a hidden quadratic, because this x to the 4 is the same as x squared squared. By laws of indices, we can rewrite it as x squared all squared. So we have a hidden quadratic in x squared. All right. So some persons might want to call that maybe u or something like that. But we can just solve for x without doing that. So let's factorize this equation now. So we're just going to factorize. Equate it to 0. Now we're going to ask ourselves which two numbers, when we multiply them, we get negative 64, but when we add them, we get negative 12. 16 times 4 will give me 64. And then what I'm saying now is, well, in order for me to get negative 12, I would need a negative 16 and a positive 4. All right, because the 4 times the 16, that would give me the 64. So I'm nice. Now we need x squared squared. For it to be x squared squared, we need a x squared here, and we need a x squared here. So now this looks just about right. If you were to test it out, x squared times x squared, that gives us back x to the 4. X squared times 16 is minus 16x squared. 4 times x squared is 4x squared. And the 4x squared and the minus 16x squared give us the 12x squared. And 4 times negative 16 is 64. So we factorize it right. Now that we factorize it right, from this part of the equation, we're getting that x squared is equal to negative 4. Now, if x squared is equal to negative 4, This has no solution because x is supposed to be a real number. X is a real number, so this is not valid. Not valid. Not valid. That's because x and y are real numbers. Since x and y are real numbers, this part cannot be valid. All right, now x squared from here is equal to 16. And so since x squared is equal to 16, what we're getting is that when we square root both sides, we get two answers. We're getting that x is equal to positive 4, or we're getting that x equal negative 4 when we square root 16. So x is positive 4 or x is negative 4. All right. Then after we get that now, we need to substitute to get y. But remember we said that y was 8 over x. Right? Y was 8 over x. Here it is again. Right here we said y was 8 over x. So since y is 8 over x, what we're virtually saying is that y is equal to 8 over 4. So in this case, y is 2, or y is negative 4, 8 over negative 4, which is negative 2. All right? So now we found the complex number. So let's zoom it down. What we know now, we finally found the complex number. We said that the complex number was x plus yi. So we can conclude now that this, let me put it in blue, we can conclude that the square root of 12 plus 16x is equal to 4 plus 2i. That's one answer, 4 plus 2i, or that's one answer. Or when x is negative 4, it's negative 4 minus 2i. I don't like to squinch it right there, so let me try to fit it somewhere else. So the square root of that is 4 plus 2i, and another answer is minus 4 minus 2i. Let's see where I can fit it. All right, let me get rid of the x and y are elements of real. So this is clear now?
Sir, I was working it out with you and that's what I got. So
Get this? Nice. Nice. Very good. Excellent. All right. So let me just write it right here now. Minus 4 minus 2i. Two answers. Nice. All right. All right. Now that we've gotten that now, let's look at the next question. Could I space this and do it on the same sheet? Let me see if I'm just gonna try to space this, see if I can space it. Yes, I can. I'm gonna space out this. All right, just taking a minute to space out the questions here. Oh, wow. All right, it's not gonna work. I was trying to convert it to Word and then space it in Word and then convert it back to PDF. It's not working. All right, that's not working. All right, so this question now, it says, if z is equal to 2 plus 4i over 1 minus 3i, evaluate in the form a plus bi. So when they give us this question, what they're asking us to do is to multiply by the complex conjugate and simplify it in the standard form of a complex number. So we're going to simplify 2 plus 4i over 1 minus 3i in the standard form of a complex number. We'll look back at the question. 2 plus 4i over 1 minus 3i. 2 plus 4, 1 minus 3. 2 plus 4i over 1 minus 3i. So what's the complex conjugate of this? 1 minus 3i.
1 plus 3i, sir.
You're absolutely right. 1 plus 3i. Beautiful. So now we're going to multiply by 1 plus 3i. We multiply both the numerator and the denominator by 1 plus 3i. So we have 1 plus 3i being divided by 1 plus 3i. Now in the numerator, we're pretty much going to expand as if we would normally with regular algebraic terms. So in the numerator, we have 2 plus 4i being multiplied by 1 plus 3i. So when we're expanding these now, it's just going to be 2 times 2 times 1 plus 3i plus 4 times the 1 plus 3i. So let's go about simplifying that. So that becomes equal to, that's equal to now 2 times 1 is 2. 2 times 3i, that is 6i. 4i times 1 is plus 4i. And then we have 4i times 3i, that looks like 12i squared. So we'll get plus 12i squared, 12i squared. Now in the denominator, what we're getting is 1 minus 3i times 1 plus 3i. Now 1 minus 3i times 1 plus 3i, that's a difference of 2 squared. Can we see that?
Yes, sir.
And so it becomes 1 squared minus 3i squared. And 3i squared is, the 3 times the 3 is 9. 3 times 3 is 9. And then the I times the I is I squared. So we get minus 1 minus 9i squared. So now let's just simplify. The result that we're getting now is 12i squared. As we said, I squared is negative 1. And so we have 2 minus 12, that's negative 10. So that's negative 10. And then we have plus 6i plus 4i, that's 10i. So we're getting negative 10 plus 10i. And that's being divided by 1 minus I squared. All right, but then I squared, as we know, it is negative 1. So this is minus 9 times minus 1, which is positive 9. Positive 9 plus 1 is 10. Positive 9 plus 1 is 10. And so what we're getting now is that we have negative 10 over 10, which is minus 1, plus 10i over 10 is just I. So the answer works out to be minus 1 plus I. All right, very easy. Soft. When we get these questions, we say soft with a capital T. All right, so I want you to write soft. And you have to make your teacher see when you put this capital T, so she emphasizes the soft. All right, easy, nice. So that's that question. All right, now that we put it in this form and we found that it was we found that the result was minus 1 plus I. Now the question is asking us to evaluate z squared. To evaluate z squared, we're just going to square this right here. All right, so let's go ahead and square that. So we want to work out z squared. Now we're working out z squared. Working out z squared. Z square, instead of squaring that number up there, we just can square this. Minus I plus 1, where minus 1 plus I. So we're squaring minus 1 plus I square. So when we're squaring this now, it's just first term square. Now we square negative 1, we get 1 plus twice the product of the 2 plus 2 times negative 1 times I. So it's plus 2 times negative 1 times I is minus I. So it's plus 2 times minus I plus second term square. Second term square is plus I square. Plus I square. I square, as we know, it is negative 1. So Z square works out to be 1 plus minus 1 is 0. And so we're left with minus 2I. And so Z square is minus 2I. All right? And that's the answer. Minus 2I. Easy. So we get minus 2I is the answer. Very nice. All right, now the next portion of the question, I believe it was asking for z squared minus 1 over z. Okay, just want z minus 1 over z. So z minus 1 over z, what they're asking us to do is to find, remember, we'll put z in this form, so we're using this form. So we're using minus I plus minus 1 plus I minus 1 over minus 1 plus I. So that's z minus 1 over z. So let's do that. Let's do this one in blue. So we have z minus 1 over z, and we just found that z is equal to minus I plus 1, so it becomes minus 1 plus I, and we're subtracting 1 over z. Subtracting 1 over z is subtracting 1 over minus 1 plus I. That's what we're subtracting. All right. Now, in order to subtract two real numbers, we usually group the real parts and the imaginary parts. But the thing about 1 over z is that it's not in its standard form. So to get 1 over z, to get minus 1 plus I in its standard form, to get 1 over z in its standard form, we have to multiply by the complex conjugate. So look what I'm going to do. So what I'm going to do now is, we are just going to say minus, put a bracket right here to show that we're going to simplify what 1 over z is, or we'll put it in its standard form. So we're going to write this as 1 all right, I see a way we can actually simplify it afterwards if we want. We can even simplify it afterwards. I see an easier method. That's going to be too much work. Yeah, this is an easier method. Now after we have this now, we can just think of minus 1 plus I as being divided by 1, don't it? Right?
Yes, sir.
Nice. So let's just find LCM. Let's use primary school stuff. Primary school stuff is telling us that the LCM is minus 1 plus I. Minus 1 plus I. Then we can say 1 into minus 1 plus I. That just goes 1 times. And so we get 1 into minus 1 plus I goes minus 1 plus I times. So what we're getting is minus 1 plus I times minus 1 plus I. So this part works out to be minus 1 plus I square. And then minus 1 plus I into minus 1 plus I, that just goes 1 time, so we'll get minus 1. So write it as 1 fraction. This makes it going to be easier. Now, we just found z squared. You see that? We just found z squared. So they
Yes,
gave us
sir.
a piece. They gave us a piece. Now, say if we were doing it the other way, we'd have to be doing too much calculations. We already found z squared. So we can just write minus 2i minus 2i minus 1 over minus 1 plus I. Now when you get to this stage now, given that the first part asks us to write in standard form, a plus bi, so don't stop it here. Just to be safe, like this is the final answer, but they always like it in the form a plus bi. So we can just go ahead and multiply by the conjugate of this denominator. What's the conjugate? What would be the conjugate of this?
-1 minus I, sir.
Very good, beautiful. -1 minus I. So that's the conjugate, -1 minus I. -1 minus I is indeed the conjugate. So now that we have the conjugate now, we're just going to say, okay, whoops, let's just multiply these two across now. So multiplying them across, what we're going to get is that z minus 1 over z is minus 2i times minus 1, that's positive 2i, then minus 2i times minus I, that's positive 2i square, positive 2i square. And then we have, this looks like minus 1 times minus 1, that is positive 1, and then minus 1 times minus I, that's positive I, and then in the denominator is the difference of 2 squared, because we have a plus b times a minus b. So it becomes a squared, -1 square is 1, minus b squared. B squared is going to be I squared, and I squared, so we're going to
Sir,
get
isn't that 2I plus 2I squared?
2i, -2i. Very good, thank you. 2i squared. Wonderful. Nice, that's 2i squared. Excellent. Nice. So now we know 2i squared is -2. So we have -2 plus 1. -2 plus 1, as we know it is -1. And then 2i plus I, that's plus 3i. So we get -1 plus 3i. And then we're dividing it by 1 minus I squared. I squared is -1. -1 minus -1 is positive 1. And so we get 1 plus 1, which is 2. So this is the answer. Z minus 1 over z is minus 1 plus 3i over 2. All right? And we deal with that question and we write easy. That one don't even deserve the soft. We just write too easy. All right? Because we're having fun. So we just say too easy. Nice. So right, too easy. Nice. And we leave it there. All right? So let's look at the next one. And we're good with this last part, right?
Yes, sir.
Nice. Wonderful. All right. Now let's look at question. Let's look at question. I know this question. Question 4. Question 4 came out of a textbook. All right. Question 4 came out of a textbook. Straight out of the textbook. Let's look at question 3. Question 3 says, given u square. Can I copy this question? Let me see. Copy. Please just define, please. Let's see if it will paste correctly. It pastes correctly if the question was typed in a PDF writer, but if it was typed in Microsoft Word, it's not going to copy correctly. So let's see if it was typed correct in a PDF typo. Nope, it was typed in Word. So after that, given that u square, all right, all right, it's a little out of the border, so let's fix it. Yeah, that should be fine now. Now we're good. All right, now we're good, yeah. So given that u square is minus 15 plus 8i, express u in terms of x plus yi. So they're asking us to find u virtually. All right, so they give us that u square is negative 15 plus 8i. If u square is negative 15 plus 8i, u square is negative 15 plus 8i, and they told us that u is also x plus yi. Now u is x plus yi, right? Express u in the form x plus yi. So they're literally telling us also u is equal to x plus yi. So if they tell us that u is also x plus yi, and we have u square is x plus yi, then if we square this side, right? If we square that side, we're going to get that u square is equal to x plus yi all square. And we had already worked out that x plus yi all square is x square minus y square plus 2xyi. That would be u square. So now that we have this as u square and we have this as u square, so u square is negative 15 plus 8i and u square is x square minus y square plus 2xyi. Only thing we need to do now is equate them, don't it? That makes sense to equate them, right?
Yes, sir.
Because u square equal u square. So when we're equating complex numbers, what we're going to do is equate the real parts and equate their imaginary parts. So what we're virtually saying is that negative 15 looks to be equal to x squared minus y squared. That's negative 15, x squared minus y squared. And then they're telling us that 8 is equal to 2xyi. So 8 is 2xy. Now, since 8 is 2xy, we can divide both sides by 2, and so that will tell us that 4 is x times y, 4 is x times y, 4 is x times y, and so what that is telling us then is that this implies that y is equal to 4 divided by x. Y is equal to 4 divided by x, because we divide both sides by x to get y. Now that we get y is 4 divided by x, we can substitute y equal 4 divided by x into this equation. So we can substitute y equal 4 divided by x into equation 1. Right? So we're going to sub 2 into 1. I'm just doing this to label it. It's always good when you label it. So we're going to put 2 into 1. 2 in 1. So we're going to sub equation 2 into equation 1. So we get negative 15 is equal to x squared minus y squared. Now that minus y squared now, x squared minus y squared. Now this y squared, y is 4 over x. And so we're going to write this as 4 over x all squared. Change this. This is 4 over x, 4 over x all squared. All right. And so what we're getting is negative 15 is equal to x squared minus, now this 4 square right here becomes 16 over x squared. 16 over x squared. Nice. So that's what we have now. All right. And so if we multiply this equation through by x squared, what we're going to get is negative 15 x squared is equal to x squared times x squared is x to the 4, x to the 4 minus 16. Now all we need to do is bring everything on one side, and this is pretty much another hidden quadratic. So just notice how all of these questions are done the same exact way. So bring over the minus 15 over here to get x to the 4. So get x to the 4. Bring over the minus 15x, so it becomes plus 15x squared minus 16 equals 0. So now what we have is, this is really a hidden quadratic. It's a hidden quadratic because x to the 4 can be rewritten as x squared all square. So since we can rewrite that as x squared all square, what we're going to do is factorize it. I'm going to factorize it. Equate it to 0. And so what we're saying pretty much is that we know x to the 4 is really x squared. And this is also x squared. That's the only way. X squared times x squared give us x to the 4. Now to get 16, the only way we can get 16 in this case is if we put 16 and 1. Now why is that going? Because right here, so now, where we have 16 and 1, this is plus 15. So because it's plus 15 right here, right, we're going to put a plus right here and a minus right here. All right, that's how we're going to do that. All right, x squared minus 1 times x squared plus 16. So that's what we get now. Now when we do that, the next thing is to just solve this question now. So x squared minus 1 equals 0, and so x squared is equal to 1. If x squared is equal to 1, then we know that x is equal to 1 or x is equal to negative 1. So x equal 1 or x equal negative 1 or x equal negative 1. Nice. Now right here, so now we have x squared plus 16 equal 0, and so this is telling us that x squared is equal to negative 16. X squared is equal to negative 16. Now since x squared is equal to negative 16, right? Now x squared is negative 16. So what we're virtually saying is that this has no solution. We cannot square a real number and get negative 16. So this one is not valid. NV. All right, NV. So x equal 1 or x equal negative 1. Now when x is equal to 1, we had said that the equation was y is 4 over x. So y is 4 over x, so y is equal to 4 over x, 1 over 4 over x is 4 over 1, and so y is 4 when x is 1. When x is negative 1, y is 4 over x, which is 4 over negative 1, which is negative 4. All right, so that's what we get. Easy, soft. So now we can write our solution. We have x is 1 and y is 4, x is negative 1, y is negative 4. So let's just put our answer. I'm going to, don't see the space, I'm just going to type it right here. So the answer is u is equal to x plus yi. So u is equal to x plus yi. And so u is equal to 1 plus 4i. U is equal to 1 plus 4i, or u is equal to 1 minus 4i. All right, well, that's minus 1 minus 4i. Minus 1 minus 4i. Sometimes you might find that persons write the solution like this. U is equal to, you see they put plus or minus, So a lot of times you'll see persons put u is equal to plus or minus in bracket 1 plus 4i. This is the exact same thing. U is equal to plus or minus 1 plus 4i. Alright, u equal plus or minus 1 plus 4i. That's the same thing. Because when it's the plus, you get 1 plus 4i. When it's the minus, you get minus 1 minus 4i. So that's cool?
Yes, sir.
Nice. Alright, I know we're out of time, but I want us to do one more given that we start late. I really want us to do one more. Alright, so
The
you
question isn't finished, sir.
repeat?
The question isn't finished.
Okay, yes, hence. And even after we do this hence part, I want us to do one more, alright?
Okay, sir.
Because we haven't looked at so many of these different other types. Alright, but I'll also complete the others that we haven't done and share with you, alright?
Okay,
Alright.
sir. Thank you.
So this part says hence solve oh, the question is already on the sheet right here. Alright, let me scroll up back to it. So it says hence solve z square minus dot equals 0. So I'm going to copy this part. And it said hence, that means we're going to utilize some information. All right, so now we're going to solve this information here. And so what we end up with is, let me see. All right, so what we end up with, why that's happening? What we have now is Control V. Yep. So we have z squared minus 3 plus 2i times z plus 5 plus I equals 0. Now, look what I want to do. I want you to look at 5 plus I as a bracket, all right? Look at that 5 plus I as one thing collectively, all right? When you look at it collectively as one thing, what you're going to pretty much realize is that that is like your C. So just think of the Z as x squared minus something times x plus 5 plus I. Now that would look normal, don't it, when it's a x, right?
Yes, sir.
So what we're going to do now is we're just going to use quadratic formula to solve this equation. All right, so we're just going to use quadratic formula. So using the quadratic formula, z is equal to minus b minus of negative 3 plus 2i gives us just 3 plus 2i. So that's minus b plus or minus the square root of b squared minus 4ac. B squared is going to be minus 3 plus 2i squared. So I'm just going to write 3 plus 2i squared. And the reason why I can throw away the negative part is because the negative of a squared and a squared is the exact same thing. All right, so I can throw away the minus on the outside because when you square the negative number, it's going to be the same as when you square the positive of the number. All right, minus 4 times a in this case is the coefficient of z squared, which is 1, minus 4 times 1 times c, and c is 5 plus I. So we can write 5 plus I right here, 5 plus I. And that is being divided by 2a. 2a is just 2 divided by a, and a is 1. So all of this is being divided by 2 times 1, which is 2. Now we're done. We're just using quadratic formula to find z. So we're just simplifying now. So z is equal to 3 plus 2i. Z is equal to 3 plus 2i plus or minus. Now we're going to simplify under the square root now. To simplify under the square root, well, we expand the square part first. Expanding the square part first, we're getting 3 square. 3 square is 9. Then we have plus 3 times 2i, that's 6i. We'll multiply that by 2, that's 12i. That's 12i. Plus 2i all squared, that's just plus 4i squared. That's now just plus 4i squared. Plus 4i squared. And then we're going to subtract. 4 times 1 is 4. Now 4 times 5, that's 20. But through the negative 4 is here, it's negative 20. And then the negative 4 times the I, that's just minus 4i. And so good. Nice. So we just need to simplify now what underneath that square root look like it's gonna work out to be. Alright, and it's all being divided by 2. It's all being divided by 2. And so what we're getting now is z is equal to 3 plus 2i, 3 plus 2i, plus or minus 3 plus 2i, plus or minus the square root of, now right here, so now 4i square is negative 1. So negative 1 times 4 is negative 4. Negative 4 plus 9. Negative 4 plus 9, that's 5. 5 minus 20, that's negative 15. Negative 15. And then we have 12i minus 4i, that become plus 8i. So we get negative 15 plus 8i, and the answer is being divided by 2. Now look. Ah, nice. Look what I see. Do you see what I see? Look what I see. I see the square root of negative 5 plus 8i. Well, let's go right here. The square root of, we found that negative 15 plus 8i was u squared. So if we were to square root both sides, we get the square root of u squared, which is u, and u is the square root of negative 15 plus 8i. Now what's the square root of negative 15 plus 8i? We found it, which was u, and u is 1 plus 4i, or minus 1 minus 4i. You see it?
Yes, sir.
Nice. So we can just substitute. So this square root part now we're nice. We say yes, we're basically done. Yes. Lovely. So we get the two values for z now. So what we're saying is z is equal to 3 plus 2i is equal to z 3 plus 2i plus, let's use when it was positive first. When it was positive, we got 3 plus 2i plus the square root of this was equal to 1 plus 4i. 1 plus 4i. And so this gives us one possibility. Then all of that is divided by 2. That's one option. Or let's look at when it was minus 1 minus I as well. Or z is equal to 3 plus 2i minus 1 minus 4i divided by 2. So now we get our two possible answers for z. 3 plus 2i minus 1 minus 4i, and that's being divided by 2. That's being divided by 2. All right. So that's equal to, now we can just go ahead and simplify it. Now 2i and 4i is 6i. And then we're getting 3 plus 1 is 4. 4 divided by 2 is 2. Plus 2i and 4i is 6i. 6i divided by 2 is 3i. So this works out to be 2 plus 3i, or 2 plus 3i, or that's only one answer, or the next answer that we're getting is, now 3 minus 1, 3 minus 1 is 2. 2 divided by 2 is 1. Then we have 2i minus 4i is minus 2i. So we have 1, negative 1, minus 2i. All right? Negative 1 minus 2i. All right? And that's it. 1 minus 2i. So the answers are 2 plus 3i or 1 minus 2i. And that's it. Easy. Soft. Right?
Sir, for, isn't it um 2 minus, it's 2 minus 2i over 2, right?
2
For the negative one.
right here.
So wouldn't you divide and get 1 minus I?
1 minus 2 minus, oh yes, divided by 2. Yes, minus I. Thank you. Yes, beautiful. Wonderful. Sharp. Sharp. Nice. Yes. You're absolutely right. All right. You're absolutely right. Very good. And also, when you get worksheets and homework, you remember the site that I showed you?
Yes, sir.
Yes, you can always check. You can always check your solutions right there in that website. Like it's really, really amazing. It's really amazing. All you do is just punch in the question and it work it out for you. All right. Just to verify your answer. It's good to just verify your answer so you know that you're on the right track and you know your understanding. And I want you to get straight hundreds on your homework right through. Right? Build up the GPA.
Yes,
Right?
sir.
Yes. Nice. All right. So let's look at this now. One last question. One last question. So, one last question. So you choose. You can choose which one you want us to look at. Your choice.
Number 6, sir.
Number 6. All right. Excellent choice. You choose just the right flavor. Nice. So this one utilizes De Moivre's theory. And even though we're just going to do number 6, what that means is I'll send you the solution for 4, 5, 7, and 8. All right? All right. So now let's look at number 6. So number 6 says use De Moivre's theorem to prove this. Sine 4 theta over sine theta is something with cos cube. Now, sine 4 theta over sine theta. Nice. So let's use De Moivre's theorem to do that. So first thing, we're going to start by writing down what is De Moivre's theorem. So what is De Moivre's theorem? What's De Moivre's theorem?
Sir, it states that if cos, if you have cos theta plus I sine theta raised to n, that is equal to cos n times theta plus I n times theta.
Very good, beautiful. So cos theta plus I sine theta to the n is equal to cos n theta plus I sine n theta. That is exactly De Moivre's theorem. Wonderfully said. Now, once you get this now, cos theta plus I sine theta, we know that it's equal to cos n theta plus I sine n theta. Now the question asks us for sine to the 4, right? Sine to the 4 being divided by something like sine theta. Now, when they ask you for sine to the 4 theta, what they're pretty much telling you to do is substitute n equal 4 into the equation. They're saying substitute n equal 4 into the equation. So what we're going to do is let n equal 4. Let n equal to 4. If we let n equal to 4, look what we're going to get. We let n equal to 4, what we're going to get is cos theta plus I sine theta to the 4th. So we're going to get cos theta plus I sine theta to the 4th. I don't know where this 4 comes from. Cos theta plus I sine theta to the 4th power and that's equal to cos 4 theta plus I sine 4 theta. I left off the I right here. It's equal to cos 4 theta plus I sine 4 theta. Now, once you get to this part, you're pretty much done half of the work. Now, the only thing that we know is that whenever two complex numbers are equal, their real parts are equal and their imaginary parts are equal. All right? So now all we need to do is, since we have I sine 4 theta, we have the imaginary part on the right-hand side. But we don't know the imaginary part on the left-hand side because this is not in its standard form. It's not in the form x plus yi. So we need to get it in the form x plus yi by first expanding this bracket. So let's expand the bracket on the left-hand side. So I'm going to do it in red. Expanding the bracket on the left-hand side, we're going to need to know Pascal triangle. Well, it makes it easier. Pascal triangle tells you that it's first term to the 4th. And if you don't know Pascal triangle, then in this case, you'd have to multiply out this times this times this times this 4 times. But that's going to take too long. So it's best to know Pascal triangle that tells you that it's first term to the 4th plus first term to the 4th. Now, first term to the 4th plus 4 times first term to the 4th plus 4 times the cube of the first term times the second term. All right? You know Pascal triangle?
Yes, sir.
Okay, I was just about to write it down. All right, nice. Plus 4 times cos cube. That is why I started with differentiation, because I start with differentiation because I know Pascal triangle really comes from sequence and series. All right. And so generally, I usually start with sequence and series. So I was shocked when you told me that your teacher started with complex numbers, because I was thinking that you have to know Pascal triangle from sequence and series and some other stuff from permutations. And that's just my perspective. But so now we get 4 cos cube theta times I sine theta. Then we times it by I sine theta. And then it's going to be now 6. So we have I sine theta plus, then it's going to be 6. So it's 1, 4, 6, 4, 1. So now the next coefficient is 6 times cos square. So the powers of cos is going down. So it becomes cos square theta times I sine theta all square. Now I sine theta all square is just going to be I square sine square theta. I square sine square theta. And then the next thing we're going to do is, then we're going to have plus, see how it's long to expand the left hand side, plus 4 cos theta times I sine theta cube times I sine theta cube. I sine theta cube is really I cube sine cube theta. I cube sine cube theta. I cube sine cube theta. Plus I to the fourth power sine to the fourth power. Now I to the fourth power is just I to the 4 sine to the 4 theta. So we'll get I to the 4 sine to the 4 theta. Sine to the 4 theta. Right? So good so far with expanding the left hand side?
Yes, sir.
Nice. Now, the only issue now is that we have so much term, we're going to have to decipher which term is imaginary from which is real. Now, that's where we're going to have to remember powers of I. Powers of I, and the powers of I tells us that I is equal to the square root of -1. That's I. I is the square root of -1. I square is the square, I square is the square root of -1 square. And so when we square that, we get I square is -1. Then I cube is just equal to I square times I square times I. And so since I cube is just using laws of indices, I square times I, we get that I cube is minus I. And then I to the 4 is I square times I square. And so I square times I square is equal to -1 times -1, which is +1, right? So this is good. Familiar with these, right? Powers of I,
Yes,
right?
sir.
Nice. So now using that, we can decipher that I to the 4 is going to be real. I to the 4 is going to be a real number. Cos to the 4 is a real number. 4 cos cube theta, I sine theta, that's imaginary. I square is going to be real. So all of these, we can just throw those away. We're going to throw those away. We're going to equate the imaginary part. So equating the imaginary part, this is what we're equating. This 4 cos cube I sine theta plus 4 cos I cube sine cube theta. That's 1, 2. We're going to equate that to I sine 4 theta. All right? So that's what we're getting. We're just using the imaginary sides, or equating the imaginary side to get what is sine 4 theta. So equating the imaginary side, what we're seeing is, well, we're saying that I sine to the 4 theta, I sine to the 4 theta, I sine 4 theta, I sine 4 theta, it's equal to, now, as we just mentioned, I cube is minus I. And so what we're getting is 4 cos cube theta, 4 cos cube theta, 4 cos cube, 4 cos cube theta, I sine theta. I'm just going to put sine theta. So don't worry, I don't throw away the I. I'm factorizing out the I from both of these terms. Then I'm going to write, now this I cube is minus I. So we change this plus to a minus, and we're going to write minus 4 cos cube, not cos cube, 4 cos, 4 cos, 4 cos, 4 cos theta sine cube theta. So that's what we're getting so far. Now I can put all of this times I Or I can just throw away the I off the left-hand side. Let's just throw away the I off here. Let's just get rid of that I. So this, and we obtain this equation by equating the imaginary part. So just to write a text, so this is by equating imaginary part. All right, now that we equate the imaginary parts, we get that sine 4 theta is 4 cos cube theta sine theta minus 4 cos theta sine cube theta. Now, what the question wanted was 4 sine theta divided 4 sine theta over sine theta, don't it? It was over sine theta, don't it? Let me go
Yes,
back.
sir.
Okay, it was over sine theta. So all we're going to do now is divide both sides by sine theta. So divide both sides by sine theta. And so now we have our sine theta, 4 theta over sine theta. It's equal to 4 cos cube sine theta. And it's both sides, both of these terms being divided by sine theta. Now when the numerator is being divided by the denominator, it's everything in the denominator we're dividing by sine theta. So since we're dividing everything in the denominator by sine theta, it simplifies to be 4 cos cube theta, sine theta over sine theta that cancel. And so we just left back with 4 cos cube theta, 4 cos cube theta. Don't freeze on me now, don't freeze. Okay, 4 cos cube theta. All right. And then right here now, sine cube being divided by sine, that just leaves sine square. So we'll get left back with 4 cos theta times sine square theta. 4 cos theta times sine square theta. Now when we get to this part now where we have our sine square theta, the only thing we need to really do now is say, okay, sine square theta, as we know, it is 1 minus cos square, don't it?
Yes, sir.
Nice. So let's substitute. Because we can't have a cos square here and a cos here and just sine just one coming out of the way, right? Imagine you have cos cube and you have cos cube. And this sine one come here. So this sine don't belong here. No. Sine can't come here. Sine too bright. Right? Sine too bright. We need everything to be cos cube or cos square. We need everything with cos. So what we're going to do is we're going to rewrite sine square as 1 minus cos square. So this becomes minus 4 cos theta times 1 minus cos square theta. We're almost finished. All we need to do now is use the distributive law and expand this question. And by expanding this bracket right here, we're going to be finished. So let's expand that right there now. We're almost finished. Finished strong. So we get 4 cos cube theta. So we have 4 cos cube theta. And then right now we have minus 4 cos theta times minus 1. That's minus 4 cos theta. Minus 4 cos theta. And then now that we have minus and minus, this is going to give us a plus. So we get plus 4. Minus and minus give us plus. 4 times 1 is 4. Cos theta times cos square theta, that give us cos cube theta. That give us cos cube theta. And then what we're going to say is 4 cos cube theta plus 4 cos cube theta. 4 cos cube plus 4 cos cube is 8 cos cube. 8 cos cube theta. So we'll get 8 cos cube theta minus 4 cos theta. And that's now sine 4 theta over sine theta. A very easy question. Soft with a capital T. Minus 4 cos theta. And we'll do that question, we just write soft. So we're proving it. So we just write soft. Soft with a capital T. Put an exclamation, too easy. Alright? And that's this proof.
Could just write quite easily done, sir.
Quite easily done. That's true. Let's not even write QED. We're gonna write a new one. We're gonna write Queba. Quite easily brushed aside. Quite easily brushed aside. That's the new one. Nice. All right, so now that we've completed this question, all right, so that's it. All right, and we're good with this now, right?
Yes, sir.
Nice. Very good. Now, what if they had asked you for cos 4 theta over cos theta? What would you do?
Cos 4 theta over
Cos theta.
cos theta. Well, I would just do the same thing but with the real
Very
parts.
good. Beautiful. Nice. 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 Lovely. I love when you say that, right? Getting it. We're getting it now. We're getting there. We're getting there. Wonderful. All right. And so that takes care of this 8 cos cube minus 4 cos theta. So that's it for today. I will send you the solution. Well, not tonight, but when is this due?
Friday, I think.
Okay, I'll send you the solution